Hello everyone. So today we are going to cover how can you decompose area formulas to prove other area formulas. So we're going to be using some highlighters today and some manipulatives so I can show you how to do this. But first we're going to go simple. So our rectangle formula is so we know how to find the area of a rectangle, or the area of any shape, is it's the space that's inside. So in here, we'd count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So the area of this is 28 units, because we don't have what it's called squared, because that's the area, because there's 28 units in here. But we know now that there's an area formula to help us. So we can count 1, 2, 3, 4 for the height, and 1, 2, 3, 4, 5, 6, 7 for the base. And we know if I do 7 times 4, it'll give us 28. So instead of having to count an area, if it is a rectangle, we have the formula area equals base times height. So that is how we can prove, yes, this is how the area formula for a rectangle works. Now, we've got to figure out for a parallelogram. So here I have, which I can't, hold on, let me do this. A sheet of construction paper, which is still a little big for the camera, but that's okay. And this, you don't have to have a construction paper. We're going to show it using highlighters, or if you just have a pencil. But so what we know is if I cut off, this is a rectangle. You all should know that this sheet of construction paper, even though you can't see the whole thing, is a rectangle. We could measure the base, we could measure the height to find the area of the whole thing. So the area of this will equal, if I cut off one triangle, I cut from the corner. So I cut off a piece. Hold on, let me do this a little better so you can see everything. Sorry, we're going to have some moving during this. It should still all be okay. Okay, so I have this. That almost fell. Okay, can we all see this? Okay, yes, you can see this. So I have this this trapezoid now, and I'm like, okay, well, how does the area of a rectangle, like this piece of construction paper, change to, how is that base times height the exact same as this construction paper? Well, when I cut off, so here's this, and I could measure the base, and I could measure the height to find the area. So the base is this full side and this full side. So I cut this off. This full side is the exact same. If I were to move this triangle over here to this side, magically you'd get yourself a parallelogram. Now I moved the piece of the base over here, you know, the piece of the base that was over here to be, hold on, technical difficulties, on this side. And so I moved it so the base is the exact same. Or I cut off from this corner all the way over here to there. So this is the exact same, and the height never changed. So that's how a parallelogram formula relates to a rectangle formula, and it's because we just move one piece of this rectangle over here, and then we should get the exact same area, which is why base times height still works even though we don't have 90-degree angles. So now, hold on, we can show that on our notes, okay, by saying, okay, so a parallelogram formula, what we can do is we can take off a piece here. So if I draw a line from this corner to about there, as straight as you can, if if I move this piece and I draw 2 over and 1, no, I want the bottom to stay on the bottom. Sorry. If I move this over and the bottom to still stay on the bottom, then there you go. We still have a nice parallelogram with the same area. It would still be 28 units because this was the same thing. Because I'd measure, okay, the base is 1, 2, 3, 4, 5, 6, 7, and the height is still, which this here we could say, okay, that's a right angle, so that's 4. The area of this whole thing would still be 28. So that is why the parallelogram formula of area equals base times height still works. I'm warning you right now, this video is a lot longer than your usual videos are, but all the videos in the past couple of weeks have been like 3 minutes, so you'll be fine. Okay, so now to show you why the triangle formula works. Well, once again, moving again. If we take a rectangle, like we've got right here, hold on, let me try and move this a little bit. Okay, so it won't fall off. Okay, so we've got ourselves a rectangle right here. And we know the area of this because we can measure here and we can measure here. But let's split this right in half. If I split this right in half, I get myself 2 triangles that if I lay over one another are equal. So I have a full rectangle here, and if I took, hold on, let me figure out how I line this up again. Not like that. This goes like that. There we go. So if I take this rectangle and I cut its area in half, it gives you a triangle. Because the base and the height don't change. So when you do base times height, it gives you the rectangle. But to find the triangle, sorry, my hair is in the video, I cut it in half and then I get the area of the one triangle. So that is how the area formula, that is how it relates to a rectangle formula and why it works. Because whenever you take the area of a triangle, you're really taking the area of 2 triangles, splitting it in half to create the one triangle that you're trying to find. So, let me set these down. If here we take our rectangle that we know is 28 units squared, right? It's the exact same rectangle that we have here. And we cut it right in half. And I forget about half of it. So the part I'm coloring is the part I'm forgetting about, or it can be the part you focus on. Well, I can count in here, but it's kind of hard to count these mini areas. So I can say, okay, I take this, which is 4, the height is still 4, and the base, that's 7. Well, I know the whole thing is 28, but if I cut this half off, that gives me 14 units squared. So that proves to you why area equals 1/2 base times height, why that works. Okay, here's our last example. So here we've got a picture here, and I've got it out like this. So if I have 2 trapezoids and I put them together, they could make me, there we go. They could make me either a rectangle, but this one just so happens to make a parallelogram, but we know how a rectangle and parallelogram formula relates to each other now. So if I take this, now let's say I called base 1, or this whole base 6, sorry if it's kind of hard to see. If I call this whole base 6 and the height 3, then the area of this parallelogram would be 18. But now I'm wondering, how does that relate to a trapezoid? Well, if I put 2 trapezoids together, Base 2 connects with base 1, so that's how that becomes 6. And base 1 connects with base 2 down here, and that's how that also becomes 6. But if I remove this, I'm left with one trapezoid. Base 2 is now 4, base 1 is now 2. They're still the same. Okay, right, that'd be 2 plus 4, that's 6. That is still how we got these two sides added together. And then I multiply that by 3, but because I'm not working with a full parallelogram now, I have to divide this in half, and then that gives me the area of one trapezoid, which in this case, if we use the numbers I made up, it would be 9. But that is why the area of a trapezoid formula works, because you have to add this base to this base, because this base is the same as this one, and when you add them together and multiply them by the height, it would give you the area of this whole thing, but we only want the area of a trapezoid, so you have to divide it by 2. Okay, so that is how that works. So we're saying, okay, this is base 1 and this is base 2. Well, then this is base 2 and this is base 1, because those are all the same. And then this here is the height. This here is the height. So I have to add these two together and divide by 2 to get myself the area of just one of these trapezoids. So that is why the area of 1/2 base 1 plus base 2 times height ends up working, because if you were to add these two together, it would give you a full base. But that's why we have to add this and this, the ones that are parallel together, times the height, and then divide it by 2 to get the area of one trapezoid. So like I said, video's a little bit longer than it usually is, but we had a lot to cover here, a lot to learn here. This is the one thing we're doing for this TEK. If you did not understand, please go ahead and come in the morning or after school. Get help before your test. That's always the smart way to do it. All right. Thanks, everyone. Bye.